in wet etching solution. So he has been heading R&D for not only solar, but all technologies of the company for the last 6 years, and works today as Senior Vice President, Technology and Innovation at RENA. Holger will talk to us today about wet chemical boost for high efficient passivated contact cells. Holger, finally, the floor is yours.
Thank you, Michael. I just try to make the presentation running now. This one it should be. Okay. Can you see my screen?
Works fine.
Perfect. So thank you, Michael, for the kind introduction and the chance to be the last of the speakers in the session. Actually, a great topic you have chosen. I would like to emphasize on your day 3 announcement, as you said, TOPCon and easy PERC upgrade towards higher efficiencies. I would like you guys take you right now into the world of a wet chemical equipment or process provider, especially in the perspective what we can influence by wet chemical processes and equipments for high efficient passivated contact solar cells. Perfect. So first of all, a short outline. I would like to make a brief company introduction, only one slide, I promise. And then I would like to present in a little bit a different way, saying, okay, what is important for passivated contacts, but also how is the interplay in our perspective, RENA perspective, what can influence a heterojunction of improvements in wet chemical processing, and what does it also mean to the old mainstream PERC? There I will highlight on 3 things, of course, texturing and clean. Also, we heard from the previous speakers, I'm very thanks to Leo and also to Jochen, that single-site poly wraparound seems to be solved or not solved, and there is a wet chemical tool called by RENA in polysite, which some people believe is not needed. We believe it's needed, and we will show interesting results from leading cell manufacturer why it is. And also very important question, finally, we address by our plating approach on TOPCon, but I also will show what can this plating approach make on PERC. And it's especially important, as we've seen from Leo before, the cost of ownership and the tiny differences. And everything we see we can influence and do will influence all cell technologies. And so this makes the entire thing quite exciting. And finally, I will close in my summary also with an additional process flow for TOPCon, which maybe will also give some reason for discussions in the chat and in the panel later on. As said, one slide about RENA. I think most of you know us. We are a wet chemical process equipment supplier for PV, but for entire different fields outside PV also. We are located in the Black Forest. Our headquarters is in Gütenbach. Totally, we have more than 1,100 employees. Our output this year will well above 180 million euro. We have more than 3,800 tools installed, and our vision, our motivation is to be a technology leader in wet chemical process equipment. Okay, that was it about RENA. And right now I would like to start a little bit a different approach based what we receive from the market, what we really feel and believe. And I think, but it goes a lot of reasons in parallel what previous presenters said. So in a nutshell, we see today that almost every mass production is above 22.7% in average. Everything is on mono, which is important for us for the texturing process, but it's self-speaking in these days. And you see here a list how strong is PERC actually in installed production base, roughly, that there is some heterojunction, IBC, specialties, And the N-type TOPCon, I said 2 gigawatt currently in ramping, 2 gigawatts from Jollywood, sorry, but roughly these are the numbers. And all, as my previous speaker said, everyone is claiming by publications, by institutes referring to these publications. So everyone has seen a method and an idea how we can reach even higher than 24%. At this moment, I think this race is open, but for me, it remains the question of RENA, which will be the technology with the most cost-effective impact. And there's a lot of parameters which move around, and I will refer to them and how they can influence the mainstream. So on the next slide, it's a little bit maybe overloaded, but forgive me. I try to lead you through to this slide where you can see on the left-hand side in arbitrary units efficiency ranking the different cell technologies here coming down from IBC down to NPERT. And this is a little bit plotted about the years starting from 2019 and looking into the future. And I would like to start with IBC and heterojunction. I put them together as they are for us, in our perspective, the high-end solar cell technologies, which have special sensitivities. And for example, heterojunction in terms of clean. When we look in our the project of ISC constants with the Zebra cells, we have special requirements on saw damage removal, and pyramid size is extremely large. Pyramids are wanted in this context. And if we're coming to today and for our technology roadmap in 2021, I put all the important topics blue and framed in red. And in the term of these high efficient solar cells, there will be, of course, even another improvement in the texturing, getting it more homogeneous and finally more clean. We work there on saving water to make it more attractive, to have a very lean process with a ultra cleanliness, but also a good cost of ownership. And there also shows up plating. But the important thing is it ends up for me or for RENA with a gate decision in 2022 plus or 2023. What will be the bottom cell for perovskite tandem technologies. This has been mentioned before. And there is interesting paper from Fraunhofer presented in EU PVSec, where there's also all three current cell types coming from heterojunction down to PERC and TOPCon, which can be used for the bottom cell, which will maybe play a role even beyond 2023. Now I would like to go back to the left-hand side and start with the N-type TOPCon, or continue with that kind of cell technology. The thing is, actually, it is the old N-type PERT approach, which was boosted by introduction, as Jollywood also presented before, introducing the polysilicon deposition, and whoops, we are at the TOPCon lines we see today. And already very early at the beginnings of the approaches, we've seen as RENA efficiencies above 23.6%. And two tools we believe need to be adopted. This is once the single site BSG or emitter or parasitic emitter removal, a single site inline etching tool, which also does polishing, as it was discussed in the chat before. Polishing, in our opinion, is important. And also the tool after the polysilicon is deposited, and it's mostly deposited with the effect that there is a wraparound. Also, Jochen stated this. Even everyone claims they do not have wraparound. The wraparound is such a significant that we from RENA believe that it has to be removed, or at least we see it from the activities of our customers. So You might wonder right now, with the TOPCon, we are at 23.6% to our awareness of the market. And it should start in 2020, but it not really did. So we believe in 2021, we will see more rollout of this technology, but maybe one issue that the market is hesitating is the cost. In terms of silver costs, it's also important. That's why we're believing in plating, what we noticed here. And the plating can do there a big punch, enabling bringing the cost down and bringing the TOPCon very, very close to the heterojunction. And finally, to the level where the decision has to be taken, could this be maybe the base cell for tandem cells of future? Now, finally, coming to the left-hand side again, to the big red arrow, where the PERC type cells are displayed. And I think over the last years, we as RENA have done a lot of small evolutionary jobs, improving bifaciality, improving making large cells, large wafer sizes running with the same machines, with the same number of throughputs, improving the texture, removing saw damage removal on texturing processes. But all these things we worked on were good for TOPCon, were good for PERC, and all what we learned from cleaning in the heterojunction were used also in here. So what I want to say, actually, even if the PERC roadmap comes from down here, it is strong in cost, and everything what we do from a wet chemical point of view, if it is the inoxide process done with the alkaline approach, it saves costs, it brings better polishing, but both approaches help TOPCon and always PERC. And this is the interesting race for us. As RENA, we not want to say it will be one of these cell types. It will be for sure the next years, things will be in parallel, but we need to be aware that everything we bring from the wet chemical side, we believe helps all three cell concepts, and this is also our strategy on that. So now I would like to approach and go a little bit deeper why we believe this. And I noted down here on the right-hand side our Batch N600 platform. And of course, it can do all wet chemical processes like wet benches of this type can do. I will not go there in further detail, but on the next slides, I would like to focus on some texturing and some cleaning, challenging and results, starting from the history, going into the future and telling you what this means later on for the cell concept and also for the TOPCon. I not want to bore you too long with this slide, but I think it's important to notice that we coming from the mono texturing with a very long process time with IPA, and this has changed in 2010 to additive based thing where we did our job, I have to say. And if we right now looking on the process times for PERC, in 2018, we've been there at 6 to 7 minutes, but heterojunction, due to the sensitivity of saw damage, needs much more longer, and it needs also different type of pyramids. If we're going away from this standard and looking into the future, of course, the PERC process time went down. The heterojunction remains more or less, but the throughputs of the equipment went significantly up, and they even go more up in the future. And the special thing is we want to, or we already providing 210 plus millimeter wafer layouts for that machines. And also the density of packing will be increased. And all this is combined right now that due to the new wafer quality, the saw damage removal is not anymore that necessary, and it all impacts especially the cost of PERC. And this gives another push, which, for example, cannot be used for heterojunction, but the PERC gets more powerful in cost again. just a short impression about some surface pictures, SEM pictures. And you might wonder why I show you this, but as we have right now extremely enlarged the wafer area, almost doubled. We also have to face, if we keep the pitch of the carriers, that the homogeneity of the texturing and the entire texture dosing and the flows are working like that, that we can have a homogeneous and very good reflection over long path run times. So this is our status at the moment. I noted down some pyramid size in between 1 to 3 microns and a reflection of 9.9 to 10.1%. From our competitor, we have to see that they do a different kind of job in terms of pyramid size, which is wanted to have the pyramid smaller. The pyramid range has to be also very tight, which is in some cases not, in some it is. But also reflection is something people extremely looking on, because they you expect from better reflections, better short circuit currents. But nevertheless, the thing has to be more stable. And what we here see at the market, what is a disadvantage, and why we working on that to improve the state of the art, is that the reflectivity has at the beginning a very low value, and then it swaps over a short period of runs, 20 runs, to much higher values. And this is our current R&D work, and we believe that we shortly can stabilize this in a shorter or smaller distribution of pyramid size, and a reflectivity in a level of 9.3%, and is stable over 200 runs. If we look on this work and on these results we do, this will especially TOPCon and PERC, both concepts will have a profit out of this work. And we cannot really say that we boost TOPCon. We have to say it's helpful for both. And it might get difficult for the challengers to overcome the cost performance of of PERC. So coming to another idea or thing we're working on, and we believe which will play an important role, especially at these levels of efficiency we are arriving at now. And here's some data from a mass production early this year, where we had cleaning tests. And cleaning after texturing is extremely important for heterojunction. There we learned the lessons, and right now we're trying to bring it into PERC. And the cleaning after the real texturing process can even impact efficiencies up to 0.05% ETA, what we've seen. This has to be established also on gallium doped wafers, and but this is some perspective which is also beneficial for PERC and TOPCon in the future. I would like to come right now to the inline processing. Here, a typical equipment, a typical single-side etching from RENA, and our NIAC 3 platform, which can run M12 wafers above 4,000 wafers per hour. And of course, as before, there we have the typical etching and cleaning processes, but we also will have a plating process on this platform. And this I would like to emphasize in the following slides. We heard, and I have seen in the chat, a lot of interesting discussions regarding the poly wraparound. I'm not expert in poly deposition, but what we can state as RENA is we receive a lot of cells samples. We are in one building with Jochen's teams from Fraunhofer. We know, of course, Centrotherm quite good, and all the leading suppliers worldwide. And we're receiving their TOPCon cells and wafers. And my opinion is what we've seen, and also from measurements, everyone has a wraparound. It is more dramatic or less dramatic. Some think they not really need to remove it because it's negligible. But finally, on the right-hand side, you see how we receive wafers, how they are built up, and how the poly wraparound is actually which needs to be removed and which is the stack. Yeah. What we developed and what we've done is a complete removal of the wraparound, of the poly wraparound, by the tool we call InPolySide. And we need that the BSG as can be used in one flow for cells, that it prevents etching of the emitter on the front side. So we do single side etching, which removes from the rear side all the affecting wraparounds. And finally, this can lead to a really high efficiency gain. I would like to show on the next slide. But before we switch to the next slide, again, this alkaline approach is a nice idea to improve the polishing of a typical etch isolation in PERC. Our inoxide fusion is such a product, and this will boost again cost down and efficiency up for a PERC approach. And so again, the solutions we're developing here is not exclusively in kind of technology needed for TOPCon. It is also in parallel helpful for other PERC cells approach. As I promised before, here the typical issue people see on the left-hand side, there's no poly etching done. The job for us is a removal of the poly wraparound. As you see, the reverse voltage on the left-hand side, -7 volt. On the right-hand side, where we removed it, it's almost doubled. If you look here on these early data we've been able to boost by almost 1% the efficiency. These results were done several times on different kind of samples. We see it all over, and also on a level above 23%. And we believe that this is single side etching enables an exclusive front side etching without affecting the rear side. This is the job we do, and this is for an approach where the poly wraparound needs to be removed. Coming to the second inline technology, we believe it's very powerful, important for today solar cell concepts. I start with PERC, and I will end up with TOPCon, what makes it special for here. So as everyone know, we work very long in the belief that the silver consumption will sooner or later will be a bottleneck for solar cell technology. And we work that we using, instead of screen printing and firing, a laser ablation, plating, and annealing approach. And we made progress that we, for example, from 2019 to 2020, we solved the issue that there no nitrogen is needed anymore. And we did, especially with our partner Chinko, significantly work on how it can be implemented into PERC. And also there's a certain roadmap on the right-hand side we believe in. The job has to be done. And it's especially that you have to have a look into the emitter optimization, because all emitters we face today are done for screen printing and firing, paste firing, classical approach. And as you have the freedom to operate in there, you see that you then can easily do changes which were not allowed for screen printing contacting, but can bring huge benefits for plated contacts. Due to the fact that we already can do today 10 micron laser opening, also very high currents are able. And so we believe that in a roadmap within 2 years, we can come from 22.6, which is today average, to 23.5% approach, and you're ending up with a full frontside metallization made of copper. Here's some results with our cooperation with Cinco Solar, presented from Stephen Fox during SNAC. And these results show simply what we've done, where we are, and where we see what are the potentials we can easily do. So we believe in 680 millivolts easily and above. As I said, this can be pushed by diffusion adaptations. Especially important, the selective emitter can be done much smaller, as two laser processes can be adjusted better. And as we will have a 10 microns opening, this will also bring huge impact to the front side recombination. The other approaches, as this was all R&D level, when we don't do manual handling, and the laser coding was a challenge here. But if you avoid all this, we believe that we can fulfill together with our partners the 23.5% roadmap. We will have finally a ROSE-conform solar cell metallization without any lead, which can be in the future from importance, but this has to be done with a collaboration work. And to everyone who's listening, so RENA is open to cooperate in these items with anyone who is contacting me. Coming to the challenge in TOPCon, and I think this is the most interesting part, because what we've done here on the right hand side with our partners is cell efficiencies, as you can see, in a level of 23.9%. Industrial cells we have over here, plated on both sides. And this will be a huge impact, especially as we have seen during the last year an increase of 50% in the silver cost. So on the other hand, we have seen enlargement of the wafers going from 166 to 210, and all this in combination helps if you do plating on PERC. Or if you imagine that you can use the plating on TOPCon, which is on both sides silver paste, this will be an important boost, this plating approach, for the TOPCon cells as well. I would like to wrap up already a little bit in the direction talking about, okay, generally, how we see this, and we not ignore what is published all over. The passivated context should overcome PERC by efficiency, but the thing is, what is the how to develop the cost in this scheme. So that's why we did a lot of work together with Fraunhofer in our public funded projects on TOPCon, and we looked on the potential how we can integrate especially these plating with an advantage, and it was mentioned already, to improve the bifaciality of TOPCon cells. We can lower the thickness of poly, as we will have shown here and shown also by cell results, that if you do it with a not firing through paste approach, the plating will help you in much higher voltages and bifaciality on the rear side. So this is what we're working on. As I said before, higher VOCs, lower metallization costs, and improving the bifaciality by reduce the poly thicknesses. Okay, as we've heard, the next year will show a volume rollout, I'm sure, for TOPCon. But in parallel, we will see, especially with the large wafers and maybe with some plating approaches, how the year PERC can improve yield and cost again. And this is the mainstream technology has to be beaten in terms of cost per watt peak. Coming to my final slide, and as a lot of things and chats were discussed about, I think, as I said, the blue boxes are the things where RENA is working on: texture and clean for a PERC approach, making the inoxide alkaline, cheaper, better polishing for higher voltages and higher currents, and also cleaner, very important. And you can combine it with plating and the RTP, which is a very lean and well-developed process at this moment, this will boost PERC for sure. On the other hand, I show you a TOPCon flow where we do actually after texture and clean the boron emitter, then a boron glass etch and polish. So the rear sides gets flattened, then a tunnel oxide and poly diffusion process, and this wraparound is removed. So there, in that case, you see where is the single side tools, and this can be combined with plating as well. So both can be an approach for sure. PERC is coming from 23% and will have much more challenges in coming higher, in close to 24%. TOPCon, even the RENA results show that we're starting in a level of 23.9 today. Once it is established in mass production, it will reach higher. But what will be the yield and the overall cost? And not to forget, and to close my talk, is on the very right-hand side, there is the heterojunction approach with its typical process flow. Here we worked on the cleaning. You see that cleaning is important, and also make it with low water consumption, that we have attractive, a lean process for texturing, much more advanced than it is discussed in these days often by competitors. And here also plating is in discussion. I put it in gray because here the challenge will be, it will be cost intensive additional steps. But nevertheless, as we've seen from Meyer Burger, they strongly believe in this will be the candidate for tandem perovskite. For sure, all the work is done on that. But nevertheless, on my first slides, I showed that even all other three cells were, even discussed by Fraunhofer to be bottom cells for tandems. So to close this slide, I only say for the right-hand side candidates, yield and cost will be the challenge. On the other hand side, for the PERC, how many ETA you can gain at low costs. So I think at this level of PERC, everything you add on will be more challenging. The other ones might have more potential, but the yield and the cost will be a challenge. And now I want to close my talk with this beautiful view from our headquarters. It really looks today like this. And I'm looking forward to your questions.
对，我会把我这边静音，你听。
OK。
Okay, Holger, that was very interesting, very nice that you also went beyond TOPCon and look at the benchmarks. Maybe just one question before we go to the panel. Because I think it's a lot of details and there's a lot of discussion also now going on in this chat. So let's put it then actually on the panel after which comes afterwards. But maybe quickly, so you have a lot of orders now. Everybody is expanding crazily. We've seen actually what the capacities are at the moment, and for the high efficiency technologies, they are still pretty small compared to PERC. The question is, what are you seeing when you look into your order books, how this is changing? There is, of course, one thing what we can see in the roadmaps from ITR PV or from others, but when we look into your order books, you're one of the world market leaders and everyone needs your wet benches. So what do you see there? Is the relationship changing?
Okay, Michael, of course I cannot talk about our order books. Sorry today this. As I try to state, RENA is not pushing one cell technology. We're trying to provide wet chemical equipments for general. What we see is that 2021 will be obviously more activities in TOPCon, but people hesitating due to our customers seem to hesitate due to yield and due to cost. This is what I pointed out, and I try to show solutions invented or developed by my team. It can be, don't worry guys, you can use LPCVD or whatever kind of wraparound depositing poly. We remove it and we have then a quite straightforward and good yield TOPCon process with using the in poly side. On the other hand, I think metallization costs is really challenging. We hope that the people will follow up our proposal, our work, what we've done with Chinko, what we've done with Fraunhofer, that this should be the solution for the future. I strongly believe in this. And in comparison to that, these two things need to be aligned. From the order book saying, cannot talk about it, but the challenge I try to highlight in my talk have to be overcome by TOPCon. And I'm sure there are companies out who can do it.
Okay,
so it will grow. Maybe it takes a little bit longer, but we will see latest 2022 maybe a stronger share in TOPCon.
That's a great final word, and maybe also a good time to hand over to Shravan, that he can